actually, no, I'm going to have to come back to that because I don't have my solutions handy. Sorry. Okay, Karina, we're filming? Okay. So good news, I am actually available for lunchtime support today. Who knew?
But we're not.
Yeah, I know, sorry. But if you are, I will be here from 12:30 to 1. More good news, Miss Dupree, our newest pre-calculus AQR teacher, we've had a couple in the last few weeks, but Miss Dupree, the best, is going to be getting to know you all on Thursdays while I'm in the back on the conference call and you guys are testing. Miss Dupree will be the one to pass out the test and say good luck. So, I mean, it's going to be a deep relationship there. So things are good. Tonight's homework is functional analysis round 1. I filmed that yesterday and emailed that out, so everybody should have that. If you're not getting it, you need to let me know. This one is a little bit longer. It's about 27 minutes, but it's all those F prime, F double prime relationships, and they are so darn important. And I picked a really hard question. Really hard question that you will take notes on and learn, and everything is going to be okay. At the end of this class, you're going to take a short assessment just to see how well you're doing, and I'm sure it'll be a smashing success. It's called at the end. At the end. We're not at the end, we're at what we call the beginning. Okay, so if I could get everybody up on their feet. It's been a while since we've done this. Gosh, such a long time. We're going to do a little power teaching review of continuity and differentiability. I thought about doing this in the video, and then I thought, no, I'm not going to do this at home all by myself. That would just be weird.
What page are you on? Why did you edit out the clip from the other video that we did in the beginning of the year? Just
wow, you think I've got a whole lot of time on my hands. Yeah. Okay. So the words are up here for anybody who has forgotten, but this was way back in August, before the flood, before adoption was finalized, all the things. Okay. In order for a function to be continuous, there can be no holes, no jumps, no breaks, and no vertical asymptotes. Sylvia's favorite one. The hole is considered a removable discontinuity. Okay, we're all going to do that again with pride and volume. On the count of 3. 1, 2, 3. In order for a function to be continuous, there can be no holes, no jumps, no breaks, and no vertical asymptotes. The hole is considered a removable discontinuity. Well done. Okay, I want 5 continuous functions. Take a minute, talk to somebody near you, get me as many continuous functions as you can. Talk to your neighbor, get me continuous functions. Stay away from trivial ones. Anybody that says y equals x, then y equals x squared, and y equals x cubed, and y equals x to the 4th, and any polynomial, not good enough. Generate me a good list.
What are your answers?
I'm going to say you're going to copy. Yeah. Okay, 3, 2, 1. Diego. Y equals sine of x. Love it. Kirsan. Loser. That's basically the same one. All right, Jackie. Something exotic.
E to the power of x.
E to the power of x. Henry. Square root of x. Not exotic, but I'll take it. Destiny.
Ln of x.
Natural log of x. Well done. Okay, now I need 5 functions that are discontinuous, and you have to tell me why they're discontinuous. Have a conversation with Haven.
Yeah, whatever, right?
Okay, closing out in 3, 2, 1. Sylvia.
Y equals the absolute value.
Y equals the absolute value of x. Epic fail. That is continuous.
Wait, but there's a cusp point, no?
Can you draw the function without any holes, jumps, or vertical asymptotes? A cusp point is fine for continuity.
But
it's not for the other thing. Andy.
1 over x.
1 over x. What's the problem with 1 over x? What's it called? What's the type of discontinuity? Not a jump. And no, I will not jump for you.
Oh, vertical.
No.
Right, y equals 1 over x. What's the problem?
Vertical.
It's got a vertical asymptote. at x equals 0. Okay, nice job. And Daisy?
Tan of x.
Y equals tan of x. Ooh, Daddy likes tan of x. Y equals tan of x looks like that. Vertical asymptote at pi over 2. And keeps doing that again and again and again. Michelle?
I was going to say
Arctan. Arctan is continuous. Y equals arctan of x. Y equals arctan of x looks like that. Horizontal asymptote, horizontal asymptote. It's continuous. I need 3 more discontinuous. Shia!
1 over x. No, just absolute value of x over x.
Oh, Daddy loves y equals absolute value of x over x. What kind of discontinuity? Y equals absolute, Paul, you're looking the wrong way, Paul. Y equals absolute value of x over x has a jump discontinuity. 2 more. Julissa.
Y is equal to 1 over x squared.
1 over x squared plus 1 is continuous. That's the kill. She set you up for failure. Okay, Sylvia. Y equals secant of x. Don't make me draw it, I'm not going to. So y equals 1 over x, absolute value of x over x, tan of x, secant of x, cosecant of x, cotan of x. Lots and lots and lots of examples, and everybody's okay. Good, let's keep going. Everybody's on your feet. You guys look like, no, I said on your feet and everyone's sitting down.
Hey, Joe.
Sure. Okay, if we're going to prove continuity at a point. Okay.
That was on camera.
In order for, this one you got to be careful. In order for a function to be continuous at a point, 3 steps. 3 steps, right? The first step?
F of x has to be the
Not f of x, f of c. The function is defined at that point. That's step number 1. There has to be a point there. Step number 2?
The limit from the left and
The
then
limit as x approaches c of f of x exists. I'm doing this because limit from the left, limit from the right, they got to be equal to each other. But that 3rd step, it's the important step, and everybody forgets.
every step has to be, it has to be
F of C
defined.
And the limit
Has to be defined.
have to be equal to each other, otherwise you have a hole. Everybody good? Okay, teach it to your neighbor real quick. The words are up here so you don't look foolish.
At a point, in order for a function to be continuous at a point, the function must satisfy these conditions. F of c is defined, the limit of f of x exists, and the limit of f of x equals f of c.
Alright friends, last one. Last one. Differentiability. Okay. Differentiability. In order for a function to be differentiable, some textbooks use the word smooth. Okay, if a function is smooth, I like to like smooth. Like I am smooth, which is different from being round, okay? In order for a function to be differentiable that is smooth, the function first has to be continuous. If your function's not continuous, you cannot be differentiable. Okay? So in order for a function to be differentiable that is smooth, the function must first be continuous. There can be no cusp point, right? Those like sharp points, no cusp points. And there can be no vertical tangent lines. A vertical tangent line is a problem. Vertical tangent line is a problem. Okay, talk to your neighbor about this real quick. We're going to get started.
Mr. D, what about the saddle points?
A saddle point, as long as it's smooth, that's fine.
Okay.
This leads to
Yeah. What's a critical point? And you'll see that in the video tonight. Critical point is where the derivative is equal to 0 or undefined. So both things are considered for critical points. Okay. Alright, friends, if I can get everybody back to their seats, please. Hi, dear.
If it's just
Man, your head still blocks stuff.
I want to make sure I hear Destiny's question. Destiny, your question one more time? Okay, so Destiny's question is like, if you have the graph in front of you, right, what I hear you saying is if I just gave you the graph, that's pretty easy?
No, you just have the equation.
No, but if you have the graph, continuity and differentiability, easy to determine, right? College Board's not going to give you the graph. Not going to give you the graph. So your question is, how do you know if you're differentiable? It has to do with, does your derivative exist? So let me look at this guy here, f of x equals the square root of x, for example. Is this function continuous?
Yes.
Right? It's a parent function. You know this really well. Now, is it differentiable? Well, let me find the derivative, and finding the derivative of the square root of x should be easy at this point. 1 over 2 times the square root of x. Still don't have the graph in front of you. Are there any problem areas for this graph?
Yeah.
Where?
And then anything negative.
Values of x less than 0 are going to be a problem. But if you think about the graph of the square root of x, the graph of the square root of x is not defined for any places to the left of 0. There is a place where the graph is defined and the derivative has a problem. And that's going to be at 0. So f prime does not exist at x equals 0. So if you don't have the graph, you can find the derivative, and you're looking to see, is there any place where the derivative doesn't exist? Think denominator equals 0. Think taking a square root of a negative number.
Is that even something about the number where it won't be like everywhere, like it won't be continuous everywhere?
Right, so like the graph of the square root of x is continuous, so I could say continuous for values of x greater than or equal to 0. Any value of x greater than or equal to 0, we're good. Well, what about differentiable? Where is the graph differentiable? Values greater than 0, but not 0. So you're differentiable everywhere except at x equals 0, and that's what I want to point out. And all the friends are good?
Mm-hmm. Yes.
Okay, good. So with that, I want to stop talking, because the plan is you guys are watching the video at night so that in class you're getting as much work time as possible. All the things that I would say are the homework is what you're going to do now. You've got between now and 9:19 to work on these multiple choice questions on pages 11, 12, and 13. In the event that you finish early, what I want you to do is use the time to go over your notes from last night, because we're going to take an assessment at 9:19 to see how well you really understand the process for showing a function is continuous and the process for showing a function is differentiable. We're going to focus on multiple choice till 9:19. I'm going to come around, I'm going to check to make sure you did the homework. So make sure you've got your notes available for me and you've got that orange card available for me. And I just realized I haven't taken attendance yet. And I need this job and you all need me.
The function.
What is the value of k in here? You know it's the following. Because you get the left and the right. Yeah, the left is the bottom equation. And the right. What value of k?
Then you have to like
No, the right is the bottom one.
no, yeah, no, but yeah, no, the right is the top. So it's from 2.
No. X. Yeah, Daisy. Come on, Daisy.
I think that question was about above the x-axis.
Blame it on you.
So you integrate from 0 all the way over to pi.
I'm not being You say, concept is like T. Pouring T into their mouth.
We just kept laughing.
So first you plug it in for 2, then you take the middle.
Video yesterday
now.
sent T.
I remember.
And then it's the equal.
I said this is your number. Every created creature. I don't remember.
Okay, the top one is left.
So for the friends watching the video at home, what you need to do is, no, I'm good. For the friends watching the video at home, what you want to do is work on the multiple choice questions for the next 12 minutes or so. And then I'm going to, so feel free to pause the video or fast forward the video. And then I'm going to share my solutions. And then we're going to do a 20-minute assessment. We'll do a 5-minute chunk where you're testing on your own. Then a 5-minute chunk when I'm giving you the solutions. 5-minute chunk where you're testing. 5 minutes when you're on the solutions. Be back in a minute.
Wait,
We have to solve for K.
I remember you find the equal thing here, right? The number, right? And then you equal it to kx plus 1.
Yeah,
And
so
the x you plug
see if
into.
it's continuous, right? You have to make sure there's a point. So you just plug it to like here. And since it says
So you
the
like make it
number
equal
is
to 7. And 7
With this
minus 1
equation,
equals
say
6.
plug in 2 because that doesn't work.
And then you divide
So
by
f of 2 would equal 7. 4 minus 6.
I mean 3.
So now you have to take the limit
For what
of
value?
of x approaching 2, right? So then for the limit to the left of 2, use this one because it's 2 here.
Es
So that
3,
would get
¿verdad?
7. For the limit to the right, use
Okay,
this
look.
one because it's greater than 2. So now you get 2k plus 1. It's asking what
Let's
2k
see.
will make the right equal 7.
Okay, so we know that the limit from the left and the limit from the right,
Answer C.
you know how to say combine, so they have to be equal to each other.
3 times 2
So
plus
we
1
have
is
to
7.
find
So on the left equals 7, the right equals 7. And
7, so now you equal kx plus 1 equals 7. And you know that
So basically they'll have to equal one number.
minus 1.
There you go. Friends over here, I need to see homework and our charts. Okay.
It's also here defined, but then once you define k,
No.
they're already telling you they're equal to yeah. I'm gonna give this one.
Oh, we did that already.
Yeah, he has,
I don't pay attention to it.
it's almost
It's kind of complicated. You get 2 functions, one for the left, one for the right.
So that's the thing with limits. You're talking about what happens as you get close, right? You never actually get to 1. Which is why
There's a limit of what you said. Or is it-
But also, I'm not going to.
So as x approaches 2,
Oh,
the limit
yeah,
of
yeah.
f of x from x.
No, I don't really get the hang of it.
food. If the function f is continuous, all real numbers. F of x is blah blah blah. It's not equal to. The example negative b is equal to each of the following.
I already had
I guess it should have. They would have been
Where's my
not
stuff, man? You're not dedicated.
Wait, so shouldn't it be 0?
That was a round.
Because x does not equal negative 2.
Then doesn't mean you take the limit from the level.
Wait, we could factor out. We could factor out.
Hey, Gerson.
That's gonna be.
So-
Oh yeah.
Yeah. Well, we could just put x minus 4. I mean, minus 2. X plus 2. You don't have like as a
In a way you can.
You can't because negative is
Yeah, because like you like cancel out the x plus 2.
All right, friends over here, let's see homework and
¿Qué página es? Okay.
I'm gonna take care of that in a
Oh,
bit.
no.
Oh, wait, that's your not.
But x is not equal.
And we're just about to get.
Do you have a call?
All right, Karina, we've got notes.
Yes.
Yeah.
And the question too.
Diego, take notes.
I see it.
Don't make those.
Watching the video would be a good idea.
You were absent yesterday, right? You get number 2. So the other thing you should work with. So you know how he was teaching us when it's 0 over 0? Yeah. You can do L hot or you can factor out. Yeah.
So it's -4, right?
I did factor.
Did I make it around to all the groups to check in on homework?
Yes.
So then when you factor,
Excellent.
It's -4.
you're trying to
We wanna be. Yes. Well, negative.
Yes.
S'il vous plaît.
So for tonight's homework, we just look up a video.
I've already
Porque
And on the
yes.
You didn't get my.
What's it called? I was looking for shapes like that.
Add Axel to the Axel, I'm gonna send you an email and you're gonna email me back and say I got it. Okay.
I don't remember. I just know big blue,
Right, so the one that's first negative 2 is negative 4. So
So be it on my head.
it has to be the f of negative 2 also.
Very small.
Because that's what it's supposed to be. So your function is this guy here, for value of x not equal to negative 2. What would f of negative 2?
You know,
It would have to be negative.
How do you know?
It's graph of negative 2 point.
Isn't that
And
vertical
the limit is
times
x approaches negative 2.
So it'll be
It'll be
0 and 2.
horizontal.
No, 2 is not defined. It's not differential 2, so it cannot be A,
What value?
A, not C.
How are we doing?
And horizontal times
What values are we doing?
No.
Nice, I agree with both. I agree with both. Good.
Okay, we know it's not differential 2. Not differential 0 either. Yeah, the jump is continuity.
Don't jump all over.
So G. Left so vertical. What's the difference between vertical tangent and vertical or like this?
I can do
Oh. Wait, no, vertical and it's from like the Y.
F is the function above.
It's like that one. So like, you know, it seems like on the y-axis, like it
Their
doesn't touch the
question was,
y-axis. That's a vertical aspect.
this is your function.
But then like, if
Vertical
What
tangent.
does f of negative 2 have to do So you already did the hard part. You found the
Oh,
limit.
but to make sure that it's
Yeah, I was like, what
the
is
same thing as making sure it's
that? Like, you know, like in a lower height, they should have that. Yeah, you also require
so now like
points that you're checking.
Right. But what I was, the part that I don't think you're getting.
Wait, didn't I talk to her?
Your function is, whatever it is, everywhere.
Also, you aiming for what?
Negative 2.
Can you refer to?
Oh.
So you figure out the limit to the left and the right to see where. That's negative 2, negative 4. How would you define f of negative 2 so that the function becomes continuous? Basically,
I feel the equilibrium.
and then you have a computer. Okay. Friends over here, how are we doing?
Function above.
Like
The function defined.
I think she was saying that, I think she was
Private negative.
so from the right.
She really learned
I
that.
kept getting five negative one.
So x less than.
Would it be -2? I mean, would it be 2?
Like I know what to do with that.
What if, no, we have to check that.
Oh yeah. So the derivative would be
I know I didn't live here.
yes,
Like,
just 3.
Okay, I'm assuming you guys are
It's like
just about done with the first 4.
it's 3.
Yeah.
Alright, let me tell you what you
Because I feel like whenever like
Number 1 is C,
Yes.
2 is E,
Yes.
3 is B,
Yes.
4 is D.
Yes.
Or you're gonna get
We were right. Yeah.
let's do this way.
When I do the test, I forget everything.
I am.
Because you're supposed to find the derivative.
Okay,
No, right?
if the function, if f is being multiplied,
You're looking for that prime.
Oh,
you're looking for f prime.
yeah. Okay, that was my correct hand.
So what do you do when you find for f prime?
What do you do?
You know that you can't use this one.
Okay, I'll help you.
Do you find it?
Okay, so you know how it says 3x plus 5? You find the derivative of that one, and it's just 3. And then the derivative for this one is negative 2.
But
Then you just plug in.
So,
So you can plug in nothing for
functions
3.
like this,
Then it's negative 2.
at negative 1,
Negative 1.
something happens. You don't know if it's continuous or not.
So it's 3 2.
Because if
No,
it was
that's not
continuous,
it.
then it would just be one function. Representing the whole thing.
So what you need
So you have to make sure that the left equals to the right. So what you do,
No, I go blank on this. You say, like, what happened?
and if it
No, I gotta equal blank.
Here's how many of you guys did the 14 multiple choice questions on limits yesterday?
We did
The 14 multiple choice questions, I said that was an next opportunity to go above and beyond. Come on over.
With the packet.
And bring your
No,
arm.
I don't even
inside.
I don't even. I just gotta keep doing it. Yeah, write it down.
Well, ready to do
I've already. That's fine. I know what you mean though. Dude, keep doing your problem.
You can do it.
Yeah. That way there you can check it.
So what's the answer? Because don't worry about the word. It's multiple choice. Prime.
All right. Here we go. Marker right around. Number 1 is C.
So that 2 does
2
not.
B.
You go in there.
3 C.
Yeah,
4
that
A. 5 C.
Okay.
6.
Yeah. Yeah, I get it. You actually get it? Yeah. I thought you did, so I was making sure that you saw it. Okay. No, yeah, I get it now.
I can take the derivative now.
Now.
Number 7 is B. Number 8 is
The graph of a function f is shown below.
Number
Which of the
9
following
is
statements is true?
If you get that, don't worry.
X
Number 10 is
graph f of x is continuous, but not
number 11 D for dynamite. Number 12 D for
You know for
dynamite.
sure that it's not the flush because it's a custom.
Number 13 is B.
Which one?
And number 14 is B.
I don't know.
B for boy.
What is the point?
Okay. So if you did all 14
Yeah, there's no
while
all.
you're here, let's do
X equals 1 and the graph of f of x is continuous and differential.
just write like extra
It's a
limit
question
questions down here
also
possible.
meaning it can't be differential. Yeah. X equals 2, the graph of x is continuous and differential. Whereas you have a line with grades and jumps. That's correct.
You could try factoring bottom and canceling.
The graph of x is shown above. If limit of q
Somewhere like
x approaching b exists, and f is not continuous at x equals b, then b equals what? So the limit exists when the left and the right equal number, but when you actually plug in b, it's not the same number as the limit. Meaning there has to be a hole.
You didn't go through the training.
So it can't be 1, so that's a point, and that's the right answer. Can't be three. Now we have 0 and
Wait a minute. Okay,
it says the limit exists. Meaning the left and the right one. And on number 2, there is something like that because there's a jump.
well, it equals 1. It's only continuous, but not different.
When you're coming together,
Because it's not.
Hi, Gonzalo. Yep.
No, but for it to be differential, you can't have
You can. The reason why you're using L'Hopital in number 2 is you need to first find the limit as x approaches -2. Because for the function to be continuous, 3 things.
No.
Function is defined.
-1.
The limit has to exist.
Oh, not. Oh,
and the limit and how the function are defined have to be the same.
Yeah.
looks like it's going to go.
I read it wrong. But I'm saying it's not differential.
L'Hopital is about finding the limit.
When I need to.
Alrighty, friends. Spoiler alert, here come all the answers.
Two's not right.
I memorized the first 4. Hold on. Number 1 is C. Number 2 is E. Number 3 is B. Number 4 is E. Destiny, what did we decide 5 was? C. Number 6? Wait. B. And number 7? E. How many all went 7 out of 7? Nice. Feels good. It's been a while.
Can you explain how?
6 out of 7. Okay. Nice. I can do it 6 out of 7. I don't have time to go over any of the multiple choice because you guys are about to do an assessment. Okay, here's the good news though. For those of you that took notes last night, you can use your notes. Do not expect this to happen all the time. It's called do your homework. Preach. Preach.
Just remember, yeah.
You do? In the 16.
22. Okay.
Do we need calculus?
Do you need calculus? Probably.
No calculator.
Calculators, no. Okay. You have 5 minutes. This should be more than enough to do part A. If you have extra time, start on part B. We're going to do 5 minutes on part A. You're going to stop. We're going to score, give you feedback. There's only one problem. There's a part A and a part B. Oh, no, not part A and part B. Sorry. Yeah. The typical question. Sorry. Sorry. Evil. Wait till you see the test on Thursday.
Oh.
3 minutes, 30 seconds. That's okay. Is anybody still working on the first question? Okay. Get about 1 more minute. If you finish with the first question, move on to the second one. Alright, if you guys could stop what you're doing, grab a marker from the supply kit, please. Make sure that this is something that is way different. Wherever most of you are somewhere in the second question, that's great. Just pause that for a little bit. And we need to talk about the first one. There are a lot of you that are moving in a good direction, but not nailing it. Okay. So here's what my work looks like and the amount of work that I'm needing to show in order to figure out differentiability. The first thing that you have to show is that the function is continuous. You have to establish continuity. To establish continuity, you need to see, is f defined at x equals 4? Yes, I can plug it in and I get 4. You have to consider the limit from the left and the limit from the right because this is a piecewise function. And some of you are like, yeah, they both check out to be 4. That's not going to be good enough. You have to use the limit notation. You have to be using this. Having a bunch of numbers on the side isn't going to cut it. Limit as x approaches 4 from the left of 16 over x is equal to 4. Limit as x approaches 4 from the right of f of x is equal to 4. If you have considered the limit from the left and the right, good news, 1 point. But you have to have the notation. If it's just numbers, cannot give you that point. Okay? So then you need to get me to your conclusion. Since f of 4 equals the limit as x approaches 4, f of x is continuous at x equals 4. That's your conclusion. That locks in a point. How many guys just picked up both points? You have to nail the notation. Have to. Yeah.
So you can't go straight to the derivative?
No, because you have to first take a stop and make sure that you have a continuous function.
Okay, what if you just did the work and just put that f of x is continuous at x equals 4?
Okay, but it sounds like what you're... So are you saying you just said f is continuous at x
No,
equals
like
4?
I showed that work and then you put that f of x is continuous at x.
So that would probably be okay, as long as you evaluated the function at 4 and checked the limits from the left and the right and you've got good notation, f is continuous at 4. 2 points. Now that you've established continuity, now you go for the kill with differentiability. Differentiability involves derivatives, and you guys should be really good with derivatives now. The derivative of 16 over x, you can use quotient rule, and you get negative 16 over x squared. The derivative of 2 square roots of x is 2 times 1 over 2 square roots of x. If you found both derivatives, 1 point. Now you've got to show me with your notation, you found the limit as x approaches 4 from the left of the derivative, and you get negative 1. The limit as x approaches 4 from the right of the derivative, and you get a half. And your conclusion?
They're not differential.
Function's not differentiable. You have continuity, but you don't have the differentiability that you need. Paul?
What if you didn't get like the same numbers, but they were still different? Like I didn't get.
So like maybe you made a mistake with the derivative somewhere. As long as this work matches your derivative, and then your conclusion matches this, you're going to be okay. You'd lose like the derivative point. So 1 point if you got both derivatives correct, 1 point for considering the limits from the left and the right, and then 1 point for your conclusion. Would be worth 5 points. How many of you guys just picked up 5 points? Okay, 4 points. I can deal with 4 points. However many points you just picked up, write that on the side of the paper so I know. Yeah.
When you take the limits, you have to do the negative 16 over x squared instead of just putting the number itself.
If you said limit as x approaches 4 from the left of f prime of x, and you said it's,
Like negative.
you went to negative 1,
Yeah.
or negative 16 over, that would be okay. Karina?
If you don't do the continuity part, do you just earn 3 points or?
If you don't do continuity, at most you can earn 3 points. I would argue they might even say no points because you haven't established this condition first. Okay, part B, 3 more minutes, see what you can do. Oh, and I need to come around and do the participation check. Am I signed everybody's card twice? Friends, time's up. The second one was tougher, I know. But that's why I wanted to, you do the first one, you get some feedback, you fix it, you move forward. Okay? Alright, so on the second one, determine the value of k which will make f a continuous function at x equals 1. Well, if f is going to be continuous, three things have to be true. F of 1 has to be defined, the limit has to exist, and all those things better be equal to each other. So f of 1, if I just plug it in, I get k over 2. And I don't know what k is right now. You take the limit as x approaches 1 from the left of f of x, and you get 4. The limit as x approaches 1 from the right is k over 2. The only way the function can be continuous if those guys are equal to each other. So k over 2 is going to be 4, and k is going to be 8. How many guys get 8? Nice. Okay, in terms of the awarding of the points, if you considered limit on the left and limit on the right, I'll say that's a point even if you came up with the wrong values. Sometimes they're kind that way. Then when you set 4 equal to k over 2 and solve it correctly, that's the second point, and I would expect most of you guys are going to get that point. Now for this value of k, determine if f is differentiable. Now we go for the derivatives. For values of x less than 1, the derivative should be easy. You get negative 4x. For values of x greater than 1, remember now k is 8. You're going to take the derivative. I would use the quotient rule. Low d high minus high d low low low. I get negative 16x over x squared plus 1 squared. Knowing that derivative gets you a point. Now limit as x approaches 1 from the left of f prime is negative 4. Limit as x approaches 1 from the right is negative 4. Your conclusion? The limit as x approaches 1 from the left of the derivative is negative 4. The limit as x approaches 1 from the right of the derivative is negative 4. My conclusion is? Differentiable. Okay, so the points here, 1 point for considering limits on left and right, 1 point for k equals 8, 1 point for finding the derivative to be negative 4x, 1 point for finding the derivative to be this guy here, 1 point for evaluating both derivative limits, and 1 point for the conclusion is out of 6. So please write out of 6 how many you earned there. Yep.
So if you did it just because I did the derivative, but I used in the limit, and I didn't write it separately, stating that it's a derivative, I would use the point. Like I just used it without writing.
No, I think you'd be okay. You'd be okay. Yeah. Yes, I'd like to see those on the way out. So Mario, if you can close the cover. I just want to see how you did, so I can figure out.